Hi everyone, I'm Jake. Today I'd like to introduce my ComfyUI extension Jake Upgrade, released on GitHub a few days ago. This extension is a practical attempt at the ComfyUI workflow, containing several workflows I use and related custom nodes. The workflows include text-to-image, image-to-image, seamless texture, image-to-mesh, and several modular single processes. Please note that the workflow is a collection of many commonly used extensions that should be installed individually. Today I will introduce the workflow of text-to-image and image-to-image, which is the most complicated. Contains 5 modules. They are the base model module, refine module, upscale module, Inpaint or Outpaint module, and detail module. Pressing the number 0 will quickly switch to the user guide, which you can learn about before use. Please pay special attention to the pre-processing of node status, which I will introduce shortly. Press the backtick button next to the number 1 to quickly switch to the overall process panel, where you can control the switch of the image generation processes. The processes includes base, fine-tune, variation, and corresponding noise injection. In addition, there are refine, upscale, detail, and Inpaint or Outpaint processes. The save image function will save the image and the corresponding metadata. Press number 1 to switch to the base model module. All colored nodes have parameters available for tuning. The project settings panel sets the project name, image name, and path name. This seed number is the version counter. There is a detailed introduction on the GitHub homepage. The output of these 2 custom loader nodes of checkpoint and V is string or string list data type. You can use the reroute to link the ComfyUI default loader nodes to the centralized management of parameters. These 2 nodes are static parameters. The so-called static means that checkpoint and V are relatively fixed after being read into the memory and will not be reloaded due to changes in other parameters. This ensures that ComfyUI reuses checkpoint and V when generating images. Therefore, static and dynamic parameters should be listed in different nodes respectively. I chose the RG3 node to control the number of seeds for the base model. In addition to the basic functions, the number of seeds in the previous queue can also be used. The base model has many parameters. The prompt is split into 2 parts based on the ELA habit. Be careful when using the SD15 ELLA. The positive prompt is filled in with a description of the image content, and the positive prompt clip is filled in with a description of the image style and quality. The same goes for negative prompt, filling in the unnecessary content, style, and quality. If ELLA is not used, the clip prompt will be merged into the positive or negative ones. You can also enable prompt input. I am currently using Portrait Master. The variation prompt is used for the variation process, which can add changes when generating images, such as changing the style or color. There are also common resolution and sampler parameters below. If you generate a seamless texture, turn on the tiling option. Specific V and image-to-image switches require pre-processing using pre-queue or pre-process, which will be demonstrated later. There are corresponding specific V and image-to-image switches in the pre-process panel. Enabling the saving of hash values can record the hash values of checkpoint and V models in the image metadata, but it will extend the saving time. I picked the SD15 checkpoint and V, entered the prompt, and adjusted the parameters. Disable SDXL text encoding and enable SD15 ELA text encoding. I then demonstrate the pre-processing required to toggle specific V and image-to-image switches. When no image generation process in the overall process panel is enabled, Clicking Queue prompt can implement preprocessing of the node status, namely prequeue. For example, if you enable image-to-image and run prequeue, the nodes related to it will be enabled, and vice versa. Specific V and image-to-image switches are closely related to the metadata storage of the image and need to be switched in the parameter panel. However, the parameter panel cannot control the node status in real time, so preprocessing is needed. Note that in version 1.0.3, a preprocessing panel has been added, and there is no need to run prequeue to preprocess the node status. This will be demonstrated later. In future updates, the parameter panel will be combined with RG3's fast muter or bypasser functions, eliminating the need for preprocessing. Next, enable the base process and run the queue. When running the queue, you will find that many nodes report errors. This is because the predecessor nodes of its process are not enabled, but this does not affect the operation of the current process. Enable Save Images. This is a complex workflow. The metadata saved by ComfyUI's default Save Image node is difficult to reflect. This custom node can save many types of metadata. Of course, the workflow JSON code will be saved when the image is saved. This is a better solution than parameter metadata, but it can only be called on ComfyUI-related platforms. The parameter metadata of the current image can be seen in the display text node. Its format follows A1111 and can be called by A1111 and related platforms. In A1111, load the image, the parameter column contains parameter metadata, and the prompt column contains JSON workflow code. Send it to the image-to-image section, and you can see that the parameters can be obtained correctly. There are three functions in the subworkflow of the basic model: SD15ELA text encoding, SDXL text encoding, and portrait master prompt input. You can enable it according to what you need. When you enable portrait master, you must also enable the additional prompt input. Enable image-to-image mode and press the backtick key to switch to the overall process panel. Make sure to close all processes for preprocessing, i.e. running the prequeue. If you forget to close all processes and run prequeue, ignoring the results of the currently running queue, the image generated by the next queue will be the correct result. A better approach is to preprocess manually in the preprocess panel of the base model. Enable the image-to-image subprocess, read in an image, adjust the base model parameters, enable the base process, and test the run. The generation is completed, and the metadata and workflow are saved along with the image to the project path according to the naming rules. Next, let's look at noise injection. In short, adding noise can give the resulting image a slight change. If interested, you can check out the video link in the description. The top one is the result of text-to-image, and the following four have noise added. These four images with added noise are similar to the one of the base process with only minor differences. Noise injection feature provides additional options while maintaining the intended appearance of the image. Please note that the noise injection feature is best done with the text-to-image workflow. This workflow also includes the process of generating pictures using various random images. Enable image-to-image and select 2, which stands for Voronoi noise in image input. Manually enable the corresponding image input preprocess, or run prequeue. This is a node of was nodes. Run it and see the result. Adjust the prompts and enable the 3 image generation processes: base, fine-tuning, and variation. I generated 2 sets of images using Voronoi noise, the first with SD15ELA text encoding enabled and the second without. It can be found that, in the current image generation process, turning off SD15Ella is easier to control. The results of the three processes are slightly different and can be filtered. Jake Upgrade also provides a concept workflow specifically designed to generate concept images. If you are interested, you can take a look. I put the link in the description. The base model module has been introduced. Next, press the number 2 key to look at the TI and auto prompt modules. The green embedding node represent positive TI, and the red node represent negative TI. This node can control the number and weight of TI. In advanced mode, you can also control the placement of TI. By turning on the append switch, TI appears after the prompt word. Otherwise, it appears in front. I picked 2 TIs for the positive and negative prompts and ran the prequeue. From the text display node, you can find that the TIs had been added. The nodes on the right are the suffixes of the prompt words for fine-tuning. When filling in the prompts, sometimes adding one more keyword, letter, or even punctuation mark will produce a different result. For more tips on image fine-tuning and variation, please refer to the video in the link. These cyan nodes represent various options for adding automatic variation prompts. The first is the variation prompt in the base model parameters panel. The second is the mixed style variation, which means whose and what style. The third to seventh ones are all automatic prompt tools, including Magic Prompt, Feeling Lucky, One Button Prompt, and Prompt Styler. I chose 3 Magic Prompt, ran the prequeue to enable the node, and ran again to see the results of the automatic prompt. Remember to fix the number of seeds after confirming the automatic prompt. Enable the 3 processes and save the image. Update the image version counter. Adjust the base prompts and run the queue. Enable the noise injection process corresponding to the 3 processes, so we have a batch of similar images to choose from. Press the number key 3 to quickly switch to Lora, ControlNet, and Advanced Model parameters. The Lora stack node can set the number and weight of Lora. The Advanced mode can set the weight of the model and clip separately. For SD15, Lora can affect both model and clip, while for SDXL, Lora only affects the model. If you are interested in this, you can watch another video of mine. I put the link in the description. I choose Niji Express and lower the weight and enable the basic process. Use the seed number of the previous queue and run the queue. Next, let's look at the usage of ControlNet. The ControlNet stack node can set the number and weight of ControlNet, and the Advanced mode can set the start and end %. Set the quantity to 1, enable the overall ControlNet switch and ControlNet Unit 1, run prequeue preprocessing, and enable the corresponding node. You can also use the preprocess panel to manually enable the corresponding node. Pick a depth map and run the queue. Reduce the ControlNet weight and run another queue. Next, let's look at the advanced model parameters. I list the nodes I often use here, including ComfyUI Upscale, SAG, LCM model sampling, FreeU, rescaling CFG, style align, and basic IPAdapter, which can be increased or decreased as needed. Advanced parameter model node states can be controlled directly without preprocessing. Let's look at the different results we get by enabling FreeU. This base IPAdapter is placed before the base model process, which can well limit the image style. Note that in the Refine module there is a more complex IPAdapter control, but that is after the basic modeling process. The refining process requires a preprocessing. For example, if we plan to refine the image generated by the base process just now, we need to enable both the base and refine processes simultaneously. Press the number key 4 to switch to the Refine module quickly. Select the process that needs refinement in the Refine process panel. Here we choose the default one, which is the base process. The refining process has many parameter settings, including refine checkpoint, number of seeds, etc. Dynamic and static parameters are placed separately like the base model parameters. Turn off SDXL text encoding. Enable Refine Checkpoint and Refine 1. Note that all switches here require preprocessing. After preprocessing, enable the base and the refine process and run the queue. This is the comparison before and after the refinement. They look quite different. This is because SD15 is different from SDXL and does not have a dedicated refinement model. Let's try to turn off the refinement seed, that is, use the seed of the base model. Try enabling the IPAdapter. You need preprocessing. I won't go into details about the parameters related to IPAdapter. I will put the link to the tutorial for using IPAdapter in the description. This workflow also provides a second step of refinement. I enabled 2 refinement processes, and Refine 2 was based on Refine 1. Preprocess panels have been added in the new version, allowing preprocessing to be done manually. Preprocessing can be done by simply turning on or off the same switch in the parameter and the preprocess panel simultaneously. There is no need to use prequeue anymore. Next, I will introduce the Upscale module. I'm going to upscale the image that the base process just generated. Press the number key 5 to quickly switch to the Upscale module. Enable the Image Upscale switch in the parameter and the preprocess panel, and set the scale to 2. The Upscale process also requires a preprocessing. Enable the Base and Upscale process in the overall process panel. Compare the results before and after upscale. We can also choose to use latent upscale, or enable latent and image upscale simultaneously and upscale twice. The workflow automatically adapts to the selected upscaler, maintaining the input upscale factor. In the Python file jake_upgrade, there is a parameter called upscale models. It lists the upscale factors of the upscaler I use, which can be customized according to the format. Let's take a look at the detailer module. The little girl in this image has an extra finger on her left hand. I'm going to use the detailer to correct this. Press the number 6 key to switch to the detailer module quickly. Enable hand fix and model differential diffusion. Model differential diffusion is a ComfyUI specific node for Inpaint. The error message says that I have not enabled the detailer process. The two hands have been identified and restored. The background is slightly different before and after restoration. We can choose other methods for detailer. In addition to handfix, there are detailers of skin, face, hands, clothes, person, and anything. These detailers are all based on the nodes in the Compact Pack custom node. Let me demonstrate by turning the girl's hair red. Turn on the hand fix and run again. Comparing the three generated images, the background differences can be weakened using the same checkpoint and seed number. Let's look at the different results of detailers one by one. Finally, I will introduce the Inpaint and Outpaint process. The Inpaint or Outpaint process requires pre-processing. Here I use the base process. Press the number key 7 to switch to the Inpaint or Outpaint module. The workflow provides 3 modes. Inpaint Simple uses the same base model, Inpaint Checkpoint uses a dedicated Inpaint model, and Outpaint Checkpoint uses a dedicated Inpaint model for image expansion. The nodes used are group nodes or component nodes provided by Jake Upgrade, that is, to complete a certain function, a group of nodes are packaged into a single component node. The result of Inpaint Simple is not ideal and can only be used for relatively small and simple repainting. Inpaint Checkpoint works well because it uses an Inpaint checkpoint corresponding to the base checkpoint. The workflow provides a tool to extract the Inpaint part of the model from the official checkpoint and merge it into any base model to generate the corresponding Inpaint model. There are 4 sets of formulas in the notes, and the addresses of the Inpaint models of SD15 and SDXL are listed. Let's look at the Outpaint image, which has been expanded by 128 pixels in all directions. First, the original image is color-blocked and the resolution is adjusted to match the Outpaint image, and then the Inpaint model is used for repainting. You can add your own workflow modules to this workflow. That's all for today. Thanks for watching.